uh, recording and welcoming everybody to our next 10-minute lesson. I'm Alana Dunoff and here today with Jim Myers, who is going to tell us all about boilers, and we're going to count and see if he gets it all in 10 minutes. So Jim, over to you.
Thank you, Alana. Glad all of you could join us today. As she said, my name is Jim Myers. I have an engineering background and spent my entire career in facilities related work. I retired about 4 years ago, and so now I'm trying to use my skills to help other people in the profession and share my knowledge. But for 10 years of my career, I was my primary job was really to go into large boiler plants and help troubleshoot problems. So I understand Corey Jackson, who's on with us, did some similar things. So he's gonna check me today. But the background that I have is obviously helpful for the topic we have today. So 10 things to know about boilers in 10 minutes. First thing is, a lot of people kind of just consider the boiler as that thing down there in the mechanical room that's a mystery to me, and it's kind of dirty, and if I have to do something about it, I'll do something, but other than that, I'm going to stay away from it. But they're really a vital part of technology and a vital part of our lives today. And while they're not perhaps as glorious as a computer chip, they're every bit important to our way of life in our society today. And they do everything from providing hot water in your homes to heating for steam and for critical uses for manufacturing processes, meeting institutional needs. But probably the most important thing about boilers is that they are involved in producing about 80% of our electricity that runs those computer chips, and so they are an important piece of technology. Number two, defining a boiler. I have it defined here as a pressure vessel with a controlled heat source that produces steam or hot water for the purpose of heating, process, or electricity generation. Sometimes they serve multiple purposes. The heat can come directly from combustion of a fuel. As you would see in this cutaway boiler, it's a gas-fired boiler with the red being the burner mechanism. Another heat source could come from another heat source, such as a waste heat boiler or a nuclear power plants where there's hot water delivered to the boiler and then produces steam. So that's your definition of a boiler. There's lots of ways to classify boilers, but I'm going to just give you a couple here. So we could separate them into hot water and steam boilers. Again, as I mentioned at the top, hot water can be used for domestic hot water or quite frequently used for heating. Steam can be used for heating. I mentioned briefly institutional applications, things like cooking, sterilization, very important in hospitals, for other kinds of equipment like laundry equipment, vital for many manufacturing processes. And as I said, very important for electricity generation. We could also classify them as high pressure and low pressure. High pressure being greater than 15 pounds and low pressure being up to 15 pounds. And that's going to bring me to my next point. I'm going to talk just a little bit about the history of boilers, and you'll see why that's so important. Of course, they were at the heart of the industrial age. In Great Britain in the early 1700s, a man named John Newcomen developed the first crude steam engine with a boiler for pumping water out of flooded areas. Much later in the 1700s, James Watt made really significant improvements to the boiler and a steam engine for manufacturing processes. And he started to include a lot of things to control the processes and control the steam engines. In the 1800s, boilers became very widely used for transportation, such as in railroads and on ships. but as well, they provided power for manufacturing using steam engines. It wasn't really till the 20th century that it became widely used for electricity. But as boilers became more popular, they grew in number, in size, and in operating pressure. And this resulted in an increasing number of explosions and disasters, many of which killed people. So that leads me to the next point, and that's governance of boilers. Here you see a steam locomotive. This is not an alien from outer space that you might see on the Sci-Fi Channel. It is boiler tubes, and they are tubes, not pipes, by the way, that have exploded and caused significant damage. Don't know from this picture whether it was loss of life. But the American Society of Mechanical Engineers, ASME, has a boiler and pressure vessel code. It was conceived in the early 1900s and first published in 1915 because of the thousands of boiler explosions in the United States and Europe. So it was really done out of a need for public safety. Today, that ASME code consists of 28 volumes and 16,000 pages, requiring every pressure part of a boiler to be manufactured to the code. That includes not just boilers, but every kind of pressure vessel, including the materials of construction, the fabrication of the materials, assemblies, and all the safety devices associated with it. Here it's just a slide showing, for example, a nameplate on a valve, and I'm going to come back to that. This would be a safety valve, and you can see it has a stamp. That's an ASME stamp on it, a V stamp because it is a valve. And there's vital information on here that as an FM that you would want to catalog and keep, not just for valves, but for the boiler itself, will have stamps on it. So today's governance, as I mentioned, the ASME code, there's quite a chain of governance in today's world. In addition to the code, the National Board is another organization. It's based in Columbus, Ohio. It maintains a record of all high pressure boilers and the inspection codes and works with all the jurisdictions and the manufacturers to update the codes. Then the states each have a boiler division, each of the 50 states with a chief boiler inspector that is responsible for annually inspecting the boilers to make sure they're being operated safely and in compliance. But the biggest part of that work is usually contracted out to insurance companies, where the states and the insurance companies work together. So again, if you're a facilities manager, you would be dealing with these inspectors, whether they're state or insurance companies. Briefly, very briefly, types of construction. This just shows, something as small as a hot water heater, whether it's electric or natural gas. And there's a lot of things that go on it, appurtenances that are important to operating that. Most boilers are steel boilers, but sometimes in smaller units, they're made of cast iron and then sections that are bolted together. This would be a small heating type of boiler. But the most prevalent kinds of boilers you'll see in larger applications are either fire tube or water tube boilers. I wanted to go over that because that's a common term. And as the name implies, a fire tube boiler is simply one where the fire and the products of combustion pass through the tubes and it's surrounded by a vessel containing water. Whereas a water tube boiler has the products of combustion and the fire that go around the boiler tubes, the water tubes, and the water then is contained inside those tubes. There's typically a top drum then for a steam boiler where the steam exits out of that boiler. So those are the brief kinds of construction. As I mentioned, lots of different subsystems to the boilers. It's not just a boiler. It's got lots of other systems to it. Some of those include, as you see here in a gas boiler, the fuel train, water supply, safety devices, and controls for all these systems. So I want to talk about a couple of myths about boilers. So the first one is the boiler is old. It's time to replace it. I bet everybody's heard that. You know, as a facility manager, a boiler is an asset. And to simply just say it's old and time to replace it is insufficient information to make a proper decision about replacing a boiler. It may be that the boiler has damage to it, the boiler, the pressure parts itself. It may be something with those subsystems, such as the fuel train or the water systems or the safety devices. But to make a statement like that is again insufficient, and you need to probe deeper and to find out really before replacing an asset, have more diagnostics on what the problem is. Can it be replaced? Can some of the subsystems be replaced or repaired, or does it really need to be replaced in whole? A second myth is a picture like this that you often see on particularly utility boilers. When you see a picture like this, it's either from another country or it's from a decades old file photo, because the emissions from boilers are highly regulated. And if something like this were to occur in our country, the plant would be shut down almost immediately and heavily fined. Now, there are differences, there are emissions that you will see. And so this is something completely different. This is actually water vapor coming out, and those are cooling towers, but you see the stacks where there isn't anything visible. So water vapor is permissible to come out of plants. And actually there is a certification, which I used to have to look at stacks and to determine, is this you know, a visible emission or steam like you see here. But certainly there is a difference in that. And so you need to be aware of that. And one last thing, just a tip for your home, for home safety. This is a repeat of the earlier slide that you saw. You see here the temperature and pressure relief valve. They're designed to open if the heater overpressurizes or overheats. Test them at least once a year using the lever on the valve, okay? And have a bucket or have a drain here so that when you open that, the hot water is going to come out. If they don't work, if nothing comes out, or they continue to leak for a day or two, replace them. I had an old timer who befriended me. He was a boiler inspector from an insurance company. And he always had the saying, if a boiler overpressurizes, it will leave the premises of the insured. And when it does, it leaves a mess. So the last item is just giving you a nice home safety tip. That's my 10 things in 12 minutes. And I'll turn it back over to Alana, but we do have 3 more of these in the series coming up.
That was awesome, Jim. I learned a little bit about boilers today, which is really awesome. So we've got 3 more lessons in our series. So next week, I'm going to tackle some accounting basics for facilities management. I don't know why, because I didn't like accounting, but I thought I've learned enough about accounting that I could talk about it for 10 minutes and perhaps impart some wisdom on to those of you, just to give basics understanding of how the finances in an organization work and go. So join me for that. I also threw in the chat a new website called Learn to Be an FM Pro. This is a little new venture. If you're interested in some other educational courses beyond just our little free 10-minute lessons here, I'm going to start using this site to define new programs. We have a Pro FM class that we're going to be gearing up for at the end of April. So you can go there, check it out if you are so interested. So that's it. Any questions or comments? Be happy to take them as we kind of wrap up here. And we, again, are so appreciative of your time and support. So thanks for being a part of our 10-minute lessons.
I'd like to hear Corey's thoughts. So what I should add or take out.
No, that was a very high level. I've been on job sites where they blow up, and it's never a good sign.
No,
it's never.
That's the number one thing always is safety, of course. But.
Yeah, I think as a facilities guys, I think you can never underestimate water treatment,
right.
daily blowdowns. Just, you know, they will save a lot of headaches in the long term. And there's a lot of rework that you can happen to a boiler before you got to throw it out. So very rarely do you ever have to throw out a boiler.
Right. Yeah.
But water
maybe if
treatment
it's that
is-
little one down in the basement that's all cracked up and never been maintained, but you know, when you get into the big stuff, they're assets.
Yeah, I think when you're when you're up to 150 horsepower, 200 horsepower boilers, water treatment, you can't say enough how valuable that is. It pays
Right.
for itself tenfold.
Yeah, yeah. Thanks for coming, Corey. Thanks
Yeah,
for.
thank you.
All right. Well, thanks, everybody. Enjoy your day and your weekend. And look forward to seeing everybody back next week, and bring a friend along. Why not?